Attract and Repel, A Look at Magnets by Jennifer Boothroyd. Magnetic forces are at work all around you. But what exactly is a magnet, and how do magnets work? Here on the right, we have our table of contents. Right here. Erase that. Let's try this one, see if that's any better. Yeah. So here's our table of contents. A table of contents can be used to tell you what section to go look for certain information. Remember, nonfiction, it doesn't matter what order you read it in. You don't have to start from the beginning. You could start in the middle because it's just teaching you things about the topic. So this tells you, here I'm going to find things that magnets stick to. Here I'm going to learn about the forces between magnets, their poles, how the Earth has magnets, and then in our lives, how we use magnets. Magnet stick, remember this is the heading right here. Maybe I need to go, let's do this one. Well, that didn't help very much, did it? This magnets stick is the heading. So we're going to learn about what magnets stick to as well as what sticks to a magnet. Drawings, a lunch menu, photos. Many people have things on their refrigerators, but what makes them stick? A magnet is an object that sticks to some metals. Some magnets are natural. Lodestone is a natural magnet. Lodestone is a kind of mineral. Most magnets are made by people. Man-made magnets come in many shapes. So these could be magnets you might find on your refrigerator. And then our caption down here says, man-made magnets can be shaped like horseshoes, discs, or bars. They come in other shapes too. So this tells you about the picture, and it's got the little arrow that points to one of the examples of the man-made magnets. A magnet attracts only certain kinds of metals. So here's they call that a horseshoe magnet. It's in the shape of a U. And here's coins. Here's another caption. A magnet sticks to this metal, but magnets will not stick to all metals. Here's a magnet sticks to steel. So since this is right by the sentence says that a magnet sticks to steel, I'm going to assume that this is steel here, these little pieces. A magnet sticks to iron. Here's your iron right here. For those of you in my class, we saw the iron filings that followed the magnet that I had. Magnets do not stick to aluminum. They do not stick to copper. Okay, so here they're showing these things are not attracted to the magnet. These things are because they're stuck onto it. These copper bits are not attracted to the magnet, but the steel bits above them are. So the silver things are steel, and down here is copper. Magnets do not stick to wood, cloth, or plastic either. Wood, plastic, and then your socks are made of cloth. Here's our next heading, magnetic force. So we're going to learn about the forces between magnets. A magnet can move an object without touching it. Magnets move objects through magnetic force. The force is invisible. You cannot see it. Invisible means something that you cannot see. Here's a caption that's going to explain this picture. Magnetic force makes this metal ball move. So that's what he's doing. He's got that horseshoe magnet that's in the shape of a U and the ball, and he's making it move around as he moves the magnet. Hold a magnet above a steel paperclip. The paperclip will fly off the table. It will stick to the magnet. Magnetic force moves from magnets into magnetic objects. So see how he's got the paper clips that are sticking to the magnet, but then he can make those other paper clips stick to the ones that are stuck to the magnet because the magnetism is going through those paper clips. Magnetic force can move from one magnetic object to another. It can move into magnetic objects that aren't even touching the magnet. The paper clips at the end of this chain aren't touching the magnet, but magnetic force moved into them through the clips at the top of the chain. Magnetic force can pass through non-magnetic materials. That's how magnets stick to this refrigerator or the fridge. The force travels through the white plastic coating and attracts metal underneath. Here's a caption to explain the picture. Magnetic force can pass through plastic as long as the plastic isn't too thick. Magnetic force can pass through many materials such as glass, paper, and cloth. So it's sticking to this hall pass paper. Magnetic force is passing through this paper. It's attracting the magnet to the metal locker. So that's what he's doing, is he's sticking it to the locker. I was wondering about that lock there. And here's another heading, magnetic poles. So the two sides of the magnet are called poles. Magnets have two poles. The poles are at the ends of a magnet. There's a north pole and a south pole. The south pole of this magnet is on the left. The north pole is on the right. There's a caption explaining the picture. Put a magnet in a bowl of steel wool clippings. Most of the metal bits will stick to the ends. A magnet's force is strongest at the poles. So on the ends are the strongest places for the magnet. What happens when you put two magnets next to each other? If two south poles or two north poles get too close, they push each other away. They repel each other. Repel is to push something away. So here they push each other away. They repel each other. Here's your caption. The south poles of these magnets are close to each other. The magnets repel each other. If opposite poles are close, the magnets move together. They attract each other, so that means to move together. Here's a caption. The north pole and the south pole of these magnets are close. The magnets attract each other. Next heading is magnetic Earth. So where do magnets exist on the Earth? How is the Earth magnetic? Earth is like a giant magnet. It has a north pole and a south pole. People learned that a magnet's north pole points toward the north pole of Earth. Inventors use this information to make the compass. Oh, the compass rose, right? Never eat soggy waffles. A compass needle has a magnetic force. It points north. Here's this caption explaining what these boys are doing. These boys use a compass to tell them which way is north. How we use magnets, our next heading. People use magnets in many ways. Magnets keep refrigerator doors closed. So here, caption, magnets in this refrigerator door help the door stay closed. You may have seen the doors at our school that are made of wood and they've got the magnets at the top, and sometimes when we have a fire drill, the magnets stop working or the doors close. We have to attach them again. They're used in speakers and earbuds, and they are also found inside computers. Giant magnets are used to make electricity, and this train uses powerful magnets to float above its track. People have found many ways to use a magnet's force. How do you think magnets will be used in the future? So they have some activities for you to do here, and you can do this at home. It's a floating paperclip. You've probably seen a balloon float in the air, but what about a paperclip? Paperclips need a little help to float. Here's how to make it happen. So you need scissors, you need clear nylon thread, like almost like fishing line if any of your family members fish, a steel clear paperclip, clear tape, a table, and different size magnets. And what you're going to do is you're going to cut a piece of thread about 6 inches long. You're going to tie one end of the thread to the paperclip and tape the other end to the table. Hold one of the magnets above the paperclip. Slowly raise the magnet so the clip lifts off the table. Keep lifting the magnet until the clip falls back down. Repeat the experiment with each of the different size magnets. Which magnets lift the clip the highest in the air? So the magnets, you can find them at like Home Depot and different hardware stores if you wanted to actually try this experiment. So now we have our glossary where they give us those important words and their definitions. So for something to attract is to pull things toward an object. And remember, magnets attract certain kinds of metals, not copper, but other types of metals. A compass is an instrument for finding directions. Compasses have a magnetic needle that always points north. A force is a push or a pull. So remember, magnets can either push away from each other or be pulled towards each other. A lodestone is a mineral that is naturally magnetic. A magnet is a piece of metal that attracts iron or steel. Non-magnetic is not attracted by a magnet. Opposite is completely different. A pole is one of the two opposite ends of a magnet. Repel is to push away.